This video will be a demonstration of how circular motion actually works. So, say we have a circle here. We have our planet here. This is our mass. Our mass, we have an imaginary field around our planet. Planet P. Mass M. Our mass is projected, right? It has a force applied to it here. We'll call this F. This will only be a single time force, a one-time force, and it will project this in a straight line until it reaches some point in this field, right? So as soon as it enters the actual zone, it will be pulled towards the center. So let's say we have a perfectly perpendicular motion to the actual radius of this field, let's say that. So in this case, we'll have that projected that way, and it will want to keep going this way, right? No, because as soon as we're there, we're going to have this force here. Now this is a constant force, and this is an accelerating force that will actually try and accelerate this linear motion towards the center. So essentially, we've got this axis. Let's call this the y-axis. Let's call this the x-axis, right? The y-axis will remain the same. Well, why will the y-axis remain the same? Because there's no other forces that are happening on the y-axis. But here, as soon as we meet this field, we've then got the x-axis here. So this is pushing it inwards. So what going to happen here is this is going to keep going in that direction. But we're accelerating that way. So this particle is going to keep moving this way, and then it's going to be pulled towards the center. But it's going to be pulled towards the center like that. So let's say by the time it moves a tiny little bit there, it's being pulled slightly over, but the speed is remaining the same. Then what's going to happen? Well, our force is no longer there. Our force is now here because our particle's moved. It's always acting towards the center. So now we can then shift the plane because we now have a new y-axis, because this tangent here will always be perpendicular to the centripetal force, which is the gravitational force here, to planet P. And this is going to keep happening over and over again. This is a large representation. It's going to happen in basically instantaneous impulses. So it's going to be constantly being pulled towards center, changes. That's going to keep happening all the way around until we basically got an orbit. It's that circular motion. It's always going to be pulled towards the center. It's not going to move towards the center. Instead, it's going to stop it from going away from the center, and it's going to be pulling it inwards towards this circle. This means that the force, or the actual force that we have in this axis here is going to be F, because when we shoot it off here, in terms of this plane, we are going to have a force there and a force here, right? Because we're moving across. This force here that's pushing it away from this line is always going to be equal to this force here. In turn, basically what's happening here is these forces are equal. So that's going to cancel out the movement of outside the circle. We're not going to get any movement inside the circle because it's the same. Therefore, the only plane we have with a movement or motion is always going to be tangential to the circle. So that's circular motion.